Now we're going to look at the technique called the addition method. Alright, so these equations are set up, notice, in a column, the x's, the y's, and the constants. And I want to add the two equations together and notice what happens. So if I write down the two equations, x plus y equals 5, and x minus y equals 1. To add these two equations together, we're going to add the columns up, just like I would do if I were adding like 3-digit numbers. I'm going to add x plus x is 2x. Y plus negative y is 0y, so I don't have any y's to write down. And 5 plus 1 is 6. So I can keep going. I can solve this for x. So I can see that x equals 3 solves that equation. Now that I know that x is 3, I can go back and find the y value using either one of these equations. So start with the top one. We'll say 3 is the x value, plus y equals 5. So if I subtract 3 from both sides, that's a weird 3, I get that y equals 2. So the solution to this system would be the ordered pair 3, 2. Now you could use the bottom equation to get y equals 2, or the top one, it doesn't matter. Go ahead and try it. Plug 3 in for x in the bottom equation, you will also come out with y equals 2. Okay, so this method is called the addition method because if I add the two equations together, I'm able to, it's also called the elimination method, I'm able to eliminate a variable and solve for the remaining variable. I want to use that same technique to solve the next problem. However, if I look at these, when I add them up, x plus 3x is 4x, 3y plus y, negative y is 3y plus negative y is 2y. No variable is going to eliminate, so that's not going to work. So instead of just adding them up, I need to multiply the entire equation by some number so that I'll get them to cancel. Alright, so backing up for a second. We know that it's okay to multiply both sides of the equation by the same number. We've done that before. That's how we solve equations. And what I'm going to look at is what I would need to do to be able to make these eliminate. For example, 3 will eliminate with a negative 3. If I multiplied this equation by a negative 3, I would be able to get those to eliminate the x's. Same thing here. 3 will eliminate with a negative 3. Since the negative is already there, if I multiply by a positive 3, I'll be able to eliminate the y's. Let's go ahead with that second suggestion. I'm going to multiply this equation here by 3, and what that's going to do, I'm looking ahead, is make this into a negative 3y so that when I add them up, I'm going to eliminate. Okay, so I'm going to write down the top equation just as it is, not changing this one at all. X plus 3y equals 7. Now I'm going to write the bottom equation multiplied by 3. This 3 is going to distribute through to every single piece. So I've got 3 times 3x makes this 9x. 3 times negative 1 is minus the 3y equals 3 times 1 is 3. Now I'm going to add up my two equations. We see that what we get is x plus 9x is 10x. As we had predicted, 3 and negative 3 will add up to 0y. And then on the other side, we add up to 10. So 10x equals 10, or x equals 1. Okay. So by figuring out what I needed to multiply by to eliminate a variable, I was able to add these and get an equation that was quickly solvable with one division, and I know my x value. So now I need to find the y value. So let's just take either equation. I'll go with the top one. X is 1. So 1 plus 3y is 7. If I subtract the 1, I started to write a 6 because I know that when I subtract the 1, I'm going to get a 6. 3y equals 6, and divided by 3, there we go, looking, I'm going too fast, I already wrote my 2 down. I get 2. Okay, so my solution here is the ordered pair 1, 2. Alright, so let's try this again. Okay, we have our summary right here. If necessary, rewrite both equations so they're in the form ax plus by equals c. So that means they need to be in columns to do this. It needs to have all the x's, the y's, and the constants lined up. Then I'm going to decide what variable to eliminate. Now you may have been wondering how I did that last time. So to decide what variable to eliminate, I'm going to look at the least common multiple. That's what I did when I looked at the coefficients. I looked for the least common multiple and choose which one to get rid of. Okay, so let me think about that here. Okay, the least common multiple of x's right here, 3 and 2 is 6. I could make those both 6's. Or for the y's, 4 and 5, I could make those both 20's. Okay, so if you had to choose between making them both 6's and making them both 20's, I think you'd probably pick the 6, purely because it's a smaller number. I'm going to be working with smaller numbers when I do this. So that's what I'm going to choose. I'm going to make these both 6's. Okay, alright, so I'm going to multiply by the number I need in order to make them both 6's. Then I'm going to add the equations, which in turn eliminates a variable. That's why this method is also known as the elimination method. And then I'm going to solve the result. Okay, so let's talk about what we need to do to get rid of the x's. Okay, I want to make these both 6's, I said. So if I multiply the top equation by 2, that's going to make the 3 turn into a 6, right? And if I multiply the bottom by 3, I will also get a 6, but I don't want another 6. Remember, I want these to add to 0, so they've got to have opposite signs. So I'm going to multiply that by a negative 3. I want them to be the same number, 6, but one needs to be a positive 6 while the other is a negative 6. So my top equation is going to be 6x plus 2 times 4 is 8y equals 18. Making sure I multiply everything there by 2. Then the next equation is going to be negative 6x minus 15y equals negative 39. Right? Multiplying everything by negative 3. Now we're going to add these two equations. Negative 6x minus 6x is 0x. 8y minus 15y is negative 7y. And 18 minus 39 is negative 21. So now when I divide both sides by negative 7, I can solve for my y value, and my y value is 3. Now that I know my y value, I'm going to go ahead and plug that in and find my x value. So it doesn't matter which equation I choose, I'm going to go ahead and pick the bottom one just for fun. So 2x plus 5 times 3, that's my y value, equals 13. So that's 2x plus 15 equals 13. Let's go ahead and subtract our 15. So I know that 2x is equal to negative 2, and once I divide by my 2, I'm going to get an x value of negative 1. So the solution that we found here is negative 1, 3. Okay, let's go ahead and look at the next one. Okay, we're going to solve this system again using the addition method. So I'm looking at the x's first. The least common denominator, or least common multiple of the x's is 2, and of the y's is 20. So out of those, the smaller value is 2, we're going to go with 2. So in this case, we're going to get rid of the x's again. Alright, so to get rid of the x's, I don't need to do anything to the first equation to make it have a 2x. It already has a 2x. So that one I won't change. 2x plus 5y equals 2. I need to multiply the bottom equation by, well, it's 1 right now, so if I multiply it by 2, it will be a 2. I don't want it to be a positive 2, though. I need it to be a negative 2, so that one of my 2's will turn out to be positive and the other one will turn out to be negative. So I'm going to multiply by negative 2. That's going to change this to a positive 8y and a positive 24. Let's add that up. 2x minus 2x is 0x. 8y plus 5y is 13y. 2 plus 24 is 26. And we've got our y. Divide by 13, y is 2. Okay, 2 seems like a popular value for y today. Alright, and let's go ahead and find x. Alright, x minus 4 times y equals negative 12. So let's go ahead, let me simplify. That's x minus 8 equals negative 12. So let's go ahead and add that 8. So I get that x is equal to negative 4. So the answer to this equation, this system of equations, is negative 4, 2. In Objective 4, I'm going to identify a system that has no solution or infinitely many solutions. We've already seen an example in the last video about identifying one of those cases with the substitution method. Now we're going to look at one with the addition method. So, again, we're going to look at x's and y's, see if I can figure out what to get rid of. If I look at 6 and 18, the least 6 and 9, the least common multiple is 18. If I look at 6 and 4, the least common multiple is 12. So let's go ahead and use the smaller one. I'm going to get rid of the y's. So to get rid of those y's, I need to multiply by 3 in the top equation to make that a 12, and by 2 in the bottom equation to make that a 12, right? 2 times 6 is 12, 3 times 4 is 12. Notice this will make a negative 12, and that one's going to be a positive 12, so the signs are already going to be correct. So let's multiply. 3 times 6 is 18, x, minus 3 times 4 is 12, y, equals 10. 2 times negative 9x is negative 18x. 2 times 6 is plus 12, y. And 2 times negative 15 is negative 30. Okay. Negative 18x plus 18x is 0. Negative 12y plus 12y is 0. So the only thing left on that side of the equation is 0. It's not 0x, it's not 0y, it's just a 0. X's and y's are both added up to 0. And then positive 10 minus 30 is negative 20. Okay, so right now someone's telling me that 0 is equal to negative 20, and I don't believe it. Oh, I made a mistake. We gotta fix that. Did you catch what I did? I did not catch it at first, but I just realized it right here. I forgot to multiply my 3 by my 10. This should have been a 30. Okay, so hopefully that wasn't too confusing. And I multiplied this 3 by everything. I multiplied it by that 10 and get a 30 right here. This 2 got multiplied by everything, and I did get the correct number here. But that means that 30 minus 30 is 0, and so I have a true statement. And like we said last time, when I have a true statement, the answer is infinitely many solutions. Infinitely many solutions is the answer, and the answer is that because this is true. Okay, now it could have happened, and I almost made a mistake and had it happen, but it could have happened that we would have gotten a false statement. If, for example, 0 is equal to 3, this is not true. That would have led to the answer no solution. Okay, so you could see how easily how that could have happened. I almost had it happen here on accident.